Now, in this lecture, we'll find out the area of a circle. In the drawing, we have quadrilateral ABCD. Inside this quadrilateral, we have a circle. And you also know that side AB of quadrilateral ABCD equals to 2 units in its length. Side BC equals to 8 units in its length. Side DC also equals to 8 units in its length. This is angle ABC that is equals to 90 degrees in its side, and this is angle DCB that is also, it is a right angle. It is equals to 90 degrees. Again, our mission is to find out the area of this circle. So first of all, we'll do construction. That is to say, we'll extend side DA and side CB of this quadrilateral until they touch each other. So this is their touching point. We define their touching point as M. We define this angle as theta. And we focus on the right big triangle, triangle MDC. On the right big triangle MDC, this angle equals to 90 degrees, this angle equals to theta, therefore the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is equals to 90 degrees, and 90 degrees plus 90 degrees, it is equals to 180 degrees. That is the sum of the angles in any triangle. Here we know that BC is one side of quadrilateral ABCD, therefore it is absolutely a straight line. Then we extended the straight line BC by straight line, and the result is CM. That must be also a straight line. Why? Because when you extend a straight line by straight line, the result must be a straight line. So CM is one straight line. So we focus on the upper side of the straight line CM at point B. Here the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of the straight line CM at point B? We have this angle that is equal to 90 degrees plus the missing angle that's actually angle ABM. In total, the sum of those two angles must be equal to 180 degrees according to the rule that I mentioned. Therefore, the missing angle must be equal to 90 degrees. Again, in order to complete the sum of the angles on the upper side of the straight line CM at point B to 180 degrees, the missing angle must be equal to 90 degrees. So this angle equals to 90 degrees. We focus on the right triangle, triangle ABM, and the right small triangle, triangle ABM. So in the right triangle ABM, this angle equals to 90 degrees. This is angle theta. So the missing angle must be equal to 90 degrees minus theta. Okay, so I'm going to now. In the next step, we'll prove that the big right triangle, triangle MDC, is similar to the small right triangle, triangle AMB. write it down. The big right triangle, triangle MDC, is similar to the small right triangle, triangle MBA. So, find those two right triangles are similar to each other. First of all, those two angles, they are both equal to 90 degrees, therefore they are equal to each other. So this is angle DCM in the big right triangle DCM. And it is equal to this angle. This is actually angle ABM in the small right triangle MBA. Repeat again. Angle DCM in the big right triangle DCM equals to angle MBA, to angle ABM in the small right triangle MBA. They are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta. It is a common angle that belongs to both triangles. So you can write down that angle theta equals to itself as a common angle that belongs to both triangles. So if you relate to angle theta as it belongs to the right big triangle DCM, it will be called angle DMC. And it equals to itself. So if we define angle theta as it belongs to, if we relate to angle theta as it belongs to the right small triangle MBA, then it will be defined as angle AMB. Repeat again. This equation means that angle theta equals to itself. We just call to angle theta two different names. Angle theta equals to itself is a common angle that belongs to both triangles. And finally, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually this is angle CDM in the big right triangle MDC, and it is equal to this angle. This is actually angle MAB. In the small right triangle MBA. Repeat again. Angle CDM equals to angle MAB. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually proved that all the fringes of the right big triangle DCM are correspondingly equal to all the fringes of the small right triangle MBA. Therefore, those two right triangles are similar to each other according to angle similarity rule. So I write it down. So the big right triangle MDC is similar. This is the sign of similar to the small right triangle MBA according to angle similarity rule. And for the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive the side DC on the big right triangle MDC over side AB in the small right triangle MBA is equals to side CM in the big right triangle MDC over side BM in the small right triangle MBA. It again. We derive that DC over AB equals to CM over BM. Okay. DC equals to 8 units in its length. So we substitute DC by 8. Over AB. Here AB equals to 2 units in its length. So we substitute AB by 2. Again, here this equals to 8 units in its length. And AB equals to 2 units in its length. And it is equals to CM. From the domain it is very easy to see that side CM in total equals to CB plus BM. That is to say, CB is equals to 8 units in its length. Here CB equals to 8 units in its length. So we substitute so in total CM equals to CB plus BM. That is to say, CB is 8, so it is 8 plus BM. CM in total equals to 8 plus BM. So we substitute CM by 8 plus BM. Here CM equals to 8 plus BM over BM. So here 8 over 2 is 4. So 4 equals to 8 plus BM over BM. Here we multiply this equation by BM. And we get that 4 times BM equals to 8 plus BM. Here we subtract bm from this equation, and we get that 4bm minus bm is 3bm. So 3bm equals to m, to 3bm equals to 8. Here we divide this equation by 3. And finally we get that bm equals to 8 over 3 units in its length. This is 97 bm, this is equal to 8 over 3 units in its length. So I write it down in the original drawing here that bm equals to 8 over 3 units in its length. So in the next step, we'll focus on this right triangle MBA, and we'll implement the Pythagoras theorem on this right triangle MBA. Here by PT is the relation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sums of the squares of the perpendiculars. The hypotenuse in the right triangle MBA is AM, so the square of the hypotenuse is AM squared, and it must be equal to AB squared plus BM squared. Repeat again. According to the Pythagoras theorem, in the right triangle MBA, AM squared equals to AB squared plus BM squared. So AM squared, that is the square of the hypotenuse, equals to AB squared. Here AB is 2, therefore AB squared is 2 squared, that is 4. Plus BM squared. BM equals to 8 over 3, therefore BM squared is 8 over 3 squared, that is actually 64 over 9. So if we found out that AM squared equals to 4 plus 64 over 9, so AM squared equals to, here we multiply 4 by 9 and then we divide it by 9 in order to have a common factor with 64 over 9. So 4 times 9 is 36. So in total, in the numerator we will have 36 plus 64 over 9. 36 plus 64, it is 100 divided by 9. So I found out that AM squared equals to 100 over 9. Here we take a root out of this equation, and we get that AM equals to the square root of 100 over 9. So the square root of 100 over 9 is the square root of 100, that is 10, over the square root of 9, that is 3. So concluding found out that AM equals to 10 over 3 units in its length. So here the hypotenuse AM equals to 10 over 4 units in its length, so I'll write it down here. AM equals to 10 over 4 units in its length. In the next step, we will do another construction. That is to say, we will draw perpendicular on BC in such a way that the perpendicular on BC will be also tangent to this circle. And again, we will draw perpendicular on BC in such a way that the perpendicular will be also tangent to this circle. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular and side BC as point T. And this perpendicular is also tangent to this circle at this point. We define the point of tendency of the perpendicular as point K, and we'll extend the perpendicular TK by a straight line until it touches side AD. We define the touching point of the extended perpendicular TK with side AD as point S. So actually, by doing this construction, we created here the big right triangle MST. In this big right triangle MST, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. In the next step, we define the center of this circle as O, this point is O. We define the point of tendency of tangent BT, this tangent BT with this circle as point H. We define the point of tendency of tangent AB with this circle as point L. We join points O and H together by straight line. Point O is the center of the circle, point H is the point of the circle itself, therefore OH is the radius of this circle. We define the radius of this circle as x, so OH is the radius of the circle, therefore it is equal to x according to our definition. And we can implement here rule 1. According to rule 1, a tangent to the circle is perpendicular to the radius drawn to its point of tendency. So in the moment we have a circle and we have this tangent AB that is tangent to this circle is point M. Point M is the point of tendency, and we have the radius OM that is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to this rule 1. We can implement rule 1 in our drawing. Well, because in our drawing we have the radius or edge of this circle that is drawn to point H, that is the point of tendency of tangent BT with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent BT will be perpendicular to the radius HO. If BT is perpendicular to HO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees. Okay, this is according to rule 1. Likewise, we join points O and K together by a straight line. OK, line segment OK is the radius of this circle that is equal to X. Again, we have the radius OK that is drawn to point K, and therefore, according to rule 1, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Likewise, we join points O and L together by a straight line. Line segment OL is the radius of this circle that is equal to X, according to our definition. The radius OL is drawn to point L, therefore, according to rule 1, this angle equals to 90 degrees, and this angle also equals to 90 degrees. We will focus on this small quadrilateral OLBA. In this small quadrilateral, we have 1, 2, 3 right angles. The sum of 3 right angles is 90 degrees times 3 is 270 degrees, plus the fourth angle. In total, they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles in this small quadrilateral OLBH to 360 degrees, the missing angle here must be equal to 90 degrees. So inside this small quadrilateral LOBH, we have 4 right angles. And therefore we can relate to this quadrilateral as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. That is to say, in rectangle LOBH, side LO must be equal to the opposite side of BH. But LO is X, therefore BH must be also equal to X. Likewise, according to the same rule, side OH must be equal to side LB in this rectangle OLBH. But OH equals to X, therefore LB must be also equal to X. So if we found out that quadrilateral OLBH is not a rectangle but a square. Why? Because all of its sides, they are equal to each other. Each side equals to X. Okay, we repeat on the same process in this small quadrilateral OKHT. In this quadrilateral, we have 1, 2, 3 right angles. Therefore, this fourth angle, the missing angle, must be also equal to 90 degrees. So this small quadrilateral TOHKOHT, this small quadrilateral has 4 right angles. And therefore, we can relate to this quadrilateral as a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, side OK must be equal to side HT, but OK is X, therefore HT must be also equal to X. And according to the sum rule, in rectangle OKHT, side OH must be equal to side KT. But OH equals to X, therefore KT must be also equal to X. So if we found out that quadrilateral OKTH, this quadrilateral is not a rectangle but a square, because all of its sides are equal to each other. In conclusion, you can write down that BT in total equals to X plus X, that is 2X. So PT equals to 2X. In the next step, we will prove that the right big triangle STM is similar to the small right triangle MBA. So I write it down. Again, we prove that the right big triangle STM is similar to the small right triangle MBA. So why those two right triangles are similar to each other? First of all, those two angles, they are both equal to 90 degrees, therefore they are equal to each other. So this is angle STM in triangle STM. And it is equal to this angle in the small right triangle MBM. It is actually angle ABM. Repeat again. Angle STM in the big right triangle STM equals to angle ABM in the small right triangle MBA. They are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta. That is a common angle. It belongs to both triangles, so we can write down that angle theta equals to itself. It's a common angle that belongs to both triangles. So if we relate to this angle theta as it belongs to the big right triangle STM, it will be called angle SMT. And it equals to itself. If we relate to angle theta as it belongs to the small right triangle MBA, it will be defined as angle AMB. Angle AMB. Repeat again. This equation means that angle theta equals to itself. We just called to angle theta two different names. And finally, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So this is angle TSM in the big right triangle STM, and it is equal to this angle, this is actually angle MAB in the small right triangle MBA. Repeat again. angle TSM in the big right triangle STM equals to angle MAB in the small right triangle MBA. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So we have to prove that all the three angles of the big right triangle STM are correspondingly equal to all the three angles of the small right triangle MBA. Therefore, those two right triangles are similar to each other according to angle similarity rule. So I write it down. The big right triangle STM is similar. This is the sign of similar to the small right triangle MBA according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that side ST in the big right triangle STM over side AB in the small right triangle MBA is equals to side TM in the big right triangle STM over side BM in the small right triangle MBA repeat again. We derive that ST over AB equals to TM over BM, and it is also equals to side SM in the big right triangle STM over side AM of the small right triangle MBA. Repeat again. In conclusion, found out that ST over AB equals to TM over BM equals to SM over AM. So ST is the missing side, so we leave it as it is. Over AB. AB equals to 2 units itself, so we substitute AB by 2. And it is also equals to TM. What is the length of TM? Here, TM in total equals to TB plus BM. That is to say, TM equals to TB, that is x plus x, that is 2x, plus BM, that is 8 over 3. So in total, TM equals to 2x plus 8 over 3. So here we substitute TM in this equation by 2x plus 8 over 3 divided by BM. BM equals to 8 over 3, so we substitute BM by 8 over 3, and it is also equals to SM over AM. SM in total equals to SA plus AM. That is to say, SM equals to SA plus AM, that is 10 over 3. So in total, SM equals to SA plus 10 over 3. So we substitute SM by SA plus 10 over 3 divided by AM. AM is 10 over 3, so we substitute AM in this equation by 10 over 3. So here, those two expressions, they are equal to each other, so we'll create equation 1 from those two equations that are equal to each other. So according to equation 1, st over 2 equals to 2x plus 8 over 3 over 8 over 3. So st over 2 equals to, here we have 2x plus 8 over 3. We multiply 2x by 3 and then we divide it by 3 in order to have a common factor with 8 over 3. And we get that 2x times 3 is 6x, so in total, in the numerator of this expression, we will have 6x plus 8 divided by 3, and it is also divided by 8 over 3. So here we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. After we cancel 3, we left only with st over 2, that is equals to 6x plus 8 over 8. So here we cross multiply this equation and we get that 8 times st equals to 2 times 6x plus 8. Here we divide this equation by 2 and we get that 8 over 2 is 4, so in total this expression equals to 4 times st. 2 over 2 is 1, so in the other side of the equation we have left only with 6x plus 8. So here we divide this equation by 4, and finally we get that st equals to 6x over 4 is 1.5x plus 8 over 4 is 2. So in conclusion, found out that st equals to 2 plus 1.5x. So I write it down in the drawing itself that st equals to 2 plus 1.5x. Here, this line segment st equals to 2 plus 1.5x. Okay. In this long equation, those two sides are also equal to each other. Therefore, we create equation 2 from those two sides that are equal to each other. So according to equation 2, we get that two x plus 8 over 3 over 8 over 3 equals to SA plus 10 over 3 divided by 10 over 3. So in this side of the equation we have 2x plus 8 over 3. Here we multiply 2x by 3 and then we divide it by 3 in order to have a common factor with 8 over 3. So 2x times 3 is 6x. So in total, in the numerator of this expression, we will have 6x plus 8 divided by 3 and all divided by 8 over 3. And it is equals to here SA plus 10 over 3 divided by 10 over 3. SA will multiply SA by 3 and then we divide it by 3 in order to have a common factor with 10 over 3. So 3 times A is 3SA. So in total, in the numerator of this expression, we will have 3SA plus 10 divided by 3 over 10 over 3. In this side of the equation, we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. In the other side of the equation, we have also 3 in the numerator and 3 in the denominator, so 3 also will get cancelled. After we cancel 3 on both sides of the equation, we left only in this side of the equation we have 6x plus 8 over 8. That equals to 3 times SA plus 10 over 10. Repeat again. After I found out that 6x plus 8 over 8 equals to 3SA plus 10 over 10. Here we'll cross multiply this equation and we get that 10 times 6x plus 8 equals to 8 times 3SA plus 10. We'll open the brackets on both sides of this equation and we'll get that before that we will divide this equation by 2 and we get here that 8 and 10 over 2 is 5. So in total in this of the equation we have 5 times 6x plus 8 that is equal to 8 over 2 is 4. So the other side of the equation in total we have 4 times 3SA plus 10. Here we'll open the brackets on both sides of this equation and we get that 5 times 6x is 30x plus 5 times 8 is 40 and it is equals to 4 times 3SA is 12SA and 4 times 10 is 40, so it is plus 40. So here we have 40 on both sides of the equation, so 40 will get cancelled. And we left only with 30x, that is equals to 12SA. Here we divide this equation by 12, and finally we get that SA equals to 30x over 12 is 2.5x. So I found out that the length of line segment SA is 2.5x. So I write it down in the original drawing itself. The line segment SA equals to 2.5x units. This is line segment SA, that is equals to 2.5x units in its length. In the next step, I will copy this quadrilateral ABST in a new pad with the circle that is inscribed inside it, and we will analyze this quadrilateral with its circle. So actually, this is quadrilateral ASBT that I got from the original drawing. This quadrilateral blocks this circle, or this circle is inscribed by quadrilateral ASBT. Okay. So here we can implement all two according to all two. The lengths of two tangents from a common standpoint to a circle are equal. We have a circle here, and this is the common standpoint point P. From the common standpoint point P, we have two tangents to this circle, tangent PA and tangent PB. And according to this, all two, they are equal to each other. That is to say, PA equals to PB, or the lengths of those two tangents, they are equal to each other in their length. PA equals to PB. We can implement all two in our drawing. Well, in our drawing, if we focus on the, but before that, we define the point of tendency of tangent AB with this circle as L. We define the point of tendency of tangent AS with this circle as K. We define the point of tendency of tangent BT with this circle as N. And finally, we define the point of tendency of tangent ST with this circle as H. And we'll focus on the common external point, point A. This common external point, point A. From the common external point, point A, we have two tangents to this circle, tangent AL and tangent AK. And according to all two, they are equal to each other. So that is to say, AL equals to AK according to all two. Repeat again. If we focus on the common external point, point A, tangent AL must be equal to tangent AK according to rule 2. So if we define the length of tangent AL as A, then the length of tangent AK must be also equal to A because they are equal to each other. So AL equals to AK equals to A. In the next step, we'll focus on the common external point, point B. On the common external point, point B, we have two tangents to this circle, tangent BL and tangent BN. According to rule 2, they are equal to each other. That is to say, BL equals to BN according to rule 2. Okay, again, tangent BL equals to tangent BL according to rule 2. So if we define the length of tangent BL as B, then the length of tangent BL must be also equal to B in its length because they are equal to each other. So you can write down that BL equals to BN equals to B. In the next step, we'll focus on the common external point, point T. From the current start point T, we have two tangents to the second. Tangent Tn and tangent Th. And according to all two, they are equal to each other. So Tn equals to Th according to the same rule, all two. Then again, Tn equals to Th according to all two. So if we define the length of tangent Tn as C, then the length of tangent Th must be also equal to C because they are equal to each other. So Tn equals to Th equals to C. And finally, we focus on the common exam point S. On the common exam point S, we have two tangents to this second, tangent SK and tangent SH, and according to all two, they are equal to each other. So SK equals to HH, according to all two. So if we define the length of tangent SK as D, then the length of tangent SH must be also equal to D because they are equal to each other. So I can write that SK equals to SH equals to D. In the next step, we will add side AS to side BT. AS plus BT. What is the value of AS plus BT? AS equals to A plus D. And BT equals to B plus C. So in total, AS plus BT equals to A plus B plus C plus D. Okay. AS plus BT equals to A plus B plus C plus D. Likewise, we will add side AB to side ST. This for the other ASBT. So it is AB plus ST. AB plus ST. AB equals to A plus D and ST equals to C plus D. So in total, AB plus ST equals to A plus B plus C plus D. So actually, those two expressions, they are both equal to A plus B plus C plus D, therefore they are equal to each other. Okay, so AS plus BT equals to AB plus ST. AS equals to 2.5x, so we substitute AS here by 2.5x plus BT. Here, BT equals to x plus x, that is 2x. Okay. So, we substitute BT by 2x. Here, BT equals to 2x. And it is equals to AB plus ST. AB equals to 2. Here, AB equals to 2. Therefore, we substitute AB by 2 plus ST. ST, this is line segment ST, this is equals to 2 plus 1.5x. So we substitute ST by 2 plus 1.5x. So in total AS plus BT is equal to AB plus ST. It is equals to 2.5x plus 2x, and it is equals to 2 plus 1.5x. So 2.5x plus 2x is 4.5x, and it is equals to 2 plus 2 is 4. So in total, in this side of the equation, we have 4 plus 1.5x. Here we substitute 1.5x from this equation, and we get that 4.5x minus 1.5x is 3x. That equals to 4. 1.5x minus 1.5x is 0. So we found out that 3x equals to 4. Here we divide this equation by 3. And finally we get that x equals to 4 over 3 units. So here the radius of this circle x equals to 4 over 3 units. So I write it down. The radius x of our circle equals to 4 over 3 units. Our mission is to find out the area of this circle. The area of any circle equals to pi times the radius square. Pi times the radius square. So the area of our circle will be equal to pi, and the radius is x. So it is pi x squared. We just right now found out that x equals to 4. So the area of our circle will be equal to pi, and x is 4. If x is 4 over 3. So if x is 4 over 3, it means that x squared will be equal to 4 over 3 squared. So in total, the area that we are looking for, that is the area of the circle, equals to pi times 4 over 3 squared. So it is pi times 4 over 3 squared. 4 over 3 squared equals to 4 squared, that is 16, over 3 squared, that is 9. So actually found out that in total the area of our circle equals to either 16 pi over 9 square units, or in terms of numbers, it equals to 5.585 square units. And that is the answer to the question. Repeat again. The area of this circle equals to either 16 pi over 9 square units, or in terms of numbers, it is equals to 5.585 square units. So in the next step, I will summarize the lecture. In this lecture, we found out the area of this circle. And again, in this lecture, we found out the area of this circle. In the drawing, we have quadrilateral ABCD. Inside this quadrilateral ABCD, we have a circle. In addition, we know that side AB of this quadrilateral equals to 2 units in itself. Side BC equals to 8 units. Side DC also equals to 8 units, This is angle ABCD is equal to 90 degrees, and this is angle DCB is also equal to 90 degrees in size. Again, our mission is to find out the area of this circle. So, in order to find out the area of this circle, we did a construction. That is to say, we extended side DA and side CB of this quadrilateral ABCD by a straight line. We extended them until they touch each other. This is their touching point. We define their touching point as M. By doing this construction, we created here the right big triangle, triangle DCM. We define this angle as theta. So then we focus on the right big triangle DCM. On this right triangle DCM, this angle equals to 40 degrees. This angle equals to theta. Therefore, the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees. And 90 degrees plus 90 degrees is equals to 180 degrees. That is the sum of the angles in any triangle. Then BC is one side of this quadrilateral ABCD, therefore it is absolutely a straight line. We extended the straight line BC by a straight line. And the result is CM. When you extend the straight line by a straight line, the result must be a straight line. So CM also is a straight line. So if you focus on the upper side of the straight line CM at point B, here the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of CM at point B? We have this angle that is equal to 90 degrees plus the missing angle, angle ABM. In total, the sum of those two angles must be equal to 180 degrees according to the rule that I mentioned. Therefore, the missing angle here must be equal to 90 degrees. In order to complete the sum of the angles of the upper side of CM at point B to 180 degrees, the missing angle here must be equal to 90 degrees. So, then we focus on this right small triangle in BM. On this small right triangle in BM, this angle equals to theta, this angle equals to 90 degrees. So the missing angle here must be equal to 90 degrees minus theta. In the next step, we proved that the big right triangle DCM is similar to the small right triangle MBA. So why those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, it is a common angle that belongs to both triangles, so we can write out that angle theta equals to itself. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So I should prove that all the three angles of the right big triangle DCM are correspondingly equal to all the three angles of the small right triangle NBA. Therefore, those two right triangles are similar to each other according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side DC on the big right triangle DCM over side AB on the small right triangle MBA equals to side CM on the big right triangle DCM over side BM of the small right triangle MBA. And repeat again, we will derive that DC over AB equals to CM over BM. DC equals to 8 units, AB equals to 2, and it is equals to CM. What is the length of CM? From the drawing it is very easy to see that CM equals to CB plus BM. Again, CM equals to CB plus BM. CB is 8, so it is 8 plus BM. So in total, CM equals to 8 plus BM. So we substitute CM here by 8 plus BM. And we have to divide it by BM. So if we found out that 8 over 2 equals to 8 plus BM over BM. 8 over 2 is 4, so 4 equals to 8 plus BM over BM. Here we multiply this equation by BM and found out that 4 times BM equals to 8 plus bm. Here we subtract bm from this equation and found out that 4bm minus bm is 3bm, so 3bm equals to 8. Here we divided this equation by 3 and finally found out that bm equals to 8 over 3, it's in the same. Here, this line segment bm equals to 8 over 3 is in its length. Then we focus on the right triangle MBM, this right small triangle MBA, and we implemented the Pythagoras theorem on this small right triangle MBA. According to the Pythagoras theorem, in this right triangle MBA, AM squared equals to AB squared plus BM squared. Repeat again. In the right triangle MBA, AM squared equals to AB squared plus BM squared. So AM squared, it is the square of the hypotenuse, equals to AB squared. AB is 2, therefore AB squared is 2 squared, that is 4. Plus bm squared. We just right now found out that bm equals to 8 over 3, therefore bm squared is 8 over 3 squared, that is actually 65 over 9. So we can found out that am squared equals to 4 plus 64 over 9. Here we multiplied 4 by 9 and then we divided it by 9 in order to find factor with 64 over 9. And found out that am squared equals to 4 times 9 is 64, 4 times 9 is 36. So in total, in the numerator we have 36 plus 64 divided by 9. 36 plus 64 is 100 divided by 9. So am squared equals to 100 over 9. We took a root out of this equation and finally found out that am equals to the square root of 100 over 9. The square root of 100 over 9 is the square root of 100 that is 10 over square root of 9 that is 3. So in total we found out that AM equals to 10 over 3 is the same. Here, this line segment, the hypotenuse AM equals to 10 over 3 is the same. Then we did another construction, that is to say, here we draw perpendicular on BC in such a way that the perpendicular on BC will be also tangent to this circle. Okay? So, this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular and side BC as T, and we define the point of tendency of the perpendicular with this circle as K. Then we extended the perpendicular TK by straight line until it touches side AD. We define the touching point of the extended perpendicular TK with side AD as point S. By doing this construction, we created here the right weak triangle STM. On the right weak triangle STM, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. Okay, then we define the center of this circle as O, this point is O. We define the point of tendency of tangent CT with this circle as K. We define the point of tendency of tangent BT with this circle as H, and we define the point of tendency of tangent AB with this circle as L. Then we join points O and N together by a straight line. Point O is the center of the circle, point H is the point of the circle itself. Therefore OH is the radius of this circle. We define the radius of this circle as X, therefore OH equals to X. So we can implement here rule 1. We have the radius OH that is drawn to point H, that is the point of tendency of tangent BT with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent BT will be perpendicular to the radius HO. If BT is perpendicular to HO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Then we join points O and L together by a straight line. OL is the radius of this circle that is equal to X. The radius OL is drawn to point L, therefore according to rule 1, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Likewise, we join points O and K together by a straight line. OK is the radius of this circle that is equal to X. The radius OK is drawn to point K, therefore according to rule 1, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Then we focus on this quadrangle OH the small quadrilateral OHTK. In this quadrilateral we have 1, 2, 3 rectangles. Therefore, the fourth angle must be also equal to 90 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So inside this quadrilateral we have 4 right angles, therefore we can relate to this quadrilateral as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. That is to say, side OK equals to side HT. But OK is x, therefore HT must be also equal to x. Likewise, according to the sum rule, side OH must be equal to side KT in rectangle OK HT. But OK is x, therefore KT must be also equal to x. So we found out that quadrilateral OK HT is not a rectangle but a square. Repeat it on the same process in this small quadrilateral OLBT, OLBH. This quadrilateral OLBH, we have 1, 2, 3 rectangles, therefore the fourth angle must be also equal to 90 degrees. Therefore, this quadrilateral OLBH, we have 4 rectangles. Therefore, we can relate to this quadrilateral as a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, in rectangle OLBH, side OL must be equal to the opposite side HB. But OL is x, therefore HB must be also equal to x. Likewise, according to the sum rule, side OH must be equal to side LB. But OH is x, therefore LB must be also equal to x. Again, we found out that quadrilateral OLBH is not a rectangle but a square. And we already found out that BT in total equals to x plus x, that is 2x. Again, BT equals to 2x. If BT equals to 2x units in its length. Then we proved that the big right triangle STM is similar to the small right triangle ABA. When those two right triangles are similar to each other. First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, it is a common angle that belongs to both triangles, so we can write down that angle theta equals to itself is a common angle that belongs to both triangles. And finally, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So we can prove that all the three angles of the big right triangle STM are correspondingly equal to all the three angles of the right small triangle MBA. Therefore, those two right triangles are similar to each other according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that side that ST over AB equals to TM over BM, and it also equals to SM over AM. So here we have ST is the missing side, so we leave it as it is. AB is 2, so we substitute AB by 2. And we have here TM. What is the length of TM? From the domain itself, it is very easy to see that Tm in total equals to Tb plus Bm. That is to say, Tm equals to Tb, that is 2x, plus Bm, that is 8 over 3. So in total, Tm equals to 2x plus 8 over 3. Here, Tm equals to 2x plus 8 over 3 over Bm. Bm is 8 over 3. Bm is 8 over 3. And it is equal to Sm. What is the length of Sm? Sm equals to SA plus AM. That is to say, Sm equals to SA, that is the missing side, plus AM. AM is 10 over 3. So in total, Sm equals to SA plus 10 over 3. If Sm equals to SA plus 10 over 3 over AM. AM equals to 10 over 3. So we substitute AM by 10 over 3. In conclusion, we found out that ST over 2 equals to 2x plus 8 over 3 over 8 over 3, and it equals to SA plus 10 over 3 over 10 over 3. Those two sides that are equal to each other, therefore we created the equation 1 from those two sides that are equal to each other. So according to equation 1, ST over 2 equals to 2x plus 8 over 3 over 8 over 3. Here we focus on this side of the equation. We have here 2x plus 8 over 3. We multiply 2x by 3 and then we divide it by 3 in order to overcome a factor with 8 over 3. So 2x times 3 is 6x. So in total, in the numerator of this expression, we have 6x plus 8. Here, 6x plus 8 divided by 3 and all divided by 8 over 3. In this side of the equation, we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. After we cancel 3, we're left only with st over 2, that is equal to 6x plus 8 over 8. Here we cross multiply this equation and found out that 8 times st equals to 2 times 6x plus 8. Here we divided this equation by 2 and found out that 8 over 2 is 4, so in total in this side of the equation we have 4st, and here we have 2 over 2 is 1, so in this side of the equation we left only with 6x plus 8. So in total 4 times st equals to 6x plus 8. Here we divided this equation by 4 and finally found out that st equals to 6x over 4 is 1.5x plus 8 over 4 is 2. So in total we found out that st equals to 1.5x plus 2 or 2 plus 1.5x. Here st, this line segment st equals to 2 plus 1.5x. And we have those two sides that are equal to each other, so we get the equation 2 from those two sides that are equal to each other. According to equation 2, 2x plus 8 over 3 over 8 over 3 equals to sa plus 10 over 3 over 10 over 3. So here we have 2x plus 8 over 3. We multiplied 2x by 3 and then we divided by 3 in order to overcome factor with 8 over 3. So in total, in the numerator of this expression, we have 2x times 3 is 6x plus 8. 6x plus 8 divided by 3, all divided by 8 over 3. On the other side of the equation, we have sa plus 10 over 3. Here we multiplied sa by 3 and then we divided by 3 in order to overcome factor with 10 over 3. So in total, in the numerator of this expression, we have 3 times sa plus 10 over 3 divided by 10 over 3. Here on both sides of the here we have 3 in this side of the equation, we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. On the other side of the equation, we have 3 in the numerator and 3 in the denominator, so 3 also will get cancelled. So what is left from from this equation after we cancel 3 on both sides of the equation? We have left only with 6x plus 8 over 8, that is equal to 3 times sa plus 10 over 10. Here we cross multiply this equation and found out that 10 times 6x plus 8 equals to 8 times 3sa plus 10. Here we divided this equation by 2. In this side of the equation we have 8 over 2 is 5, so in total in this side of the equation we have 5 times 6x plus 8, that's equal to 8 over 2 is 4. So in total in this side of the equation we have 4, inside the brackets we have 3sa plus 10. So we found out that 5 times 6x plus 8 equals to 3 times 3sa plus 10. Here we open the brackets on both sides of the equation and found out that here we have 5 times 6x is 30x plus 5 times 8 is 40. So it is plus 40, this equals to 4 times 3sa is 12sa and 4 times 10 is 40. So in total, this side of the equation we have 12sa plus 40. Here we have 40 on both sides of the equation, so 40 will get cancelled and we left only with 30x, that is equals to 12sa. Here we divided this equation by 12 and finally found out that sa equals to 2.5x. Here, this line segment sa equals to 2.5x in its length. Then I copied this quadrilateral ASTB in a new page with its circle that is inscribed by this quadrilateral ASBT. This is the quadrilateral ASBT that I copied from the original drawing with its circle that is inscribed inside it. Here we implemented rule 2, according to rule 2, if we focus on the common side point, point A, we have two tangents to this second, tangent AL and tangent AK. And according to rule 2, they are equal to each other. That is to say, AL equals to AK. AL equals to AK according to rule 2. So if we define the length of AL as A, then AK must be also equal to A because they are equal to each other. So AL equals to AK equals to A. Then we focus on the common side point, point B. On the common side point, point B, we have two tangents to this second, tangent BL and tangent BN. According to rule 2, they are equal to each other. That is to say, BL equals to BN. Here BL equals to BN according to rule 2. So if we define the length of BL as B, then BN must be also equal to B because they are equal to each other. So in total, BL equals to BN equals to B. Only to rule 2. Then we focus on the common side point, point T. From the common side point, point T, we have two tangents to this second, tangent TH and tangent TN. And according to rule 2, they are equal to each other. That is to say, TH equals to TN. Yeah, TH equals to TN. So if we define the length of TH as C, then TN must be also equal to C because they are equal to each other. So in conclusion, found the TN equals to TH equals to C. Then finally focus on the common side point, point S. On the common side point, point S, we have two tangents to the second, tangent SK and tangent SH. And according to rule 2, they are equal to each other. That is to say, SK equals to SH. SK equals to SH according to rule 2. So if we define the length of SK as D, then SH must be also equal to D because they are equal to each other. So in total, we found out that SK equals to SH equals to D. Then we added side AS to side BT in this quadrangle, AS BT. AS plus BT. And what is the length of side AS plus side BT? From the drawing, it is very easy to see that AS plus BT equals in total to A plus B plus C plus D. Again, AS plus BT equals to A plus B plus C plus D. Then we added side AB to side ST. What is the value of AB plus ST? Again, AB plus ST. From the drawing, it is very easy to see that AB is A plus B and ST is C plus D. So in total, AB plus ST equals to A plus B plus C plus D. So AB plus ST also equals to A plus B plus C plus D. So those two expressions, they are both equals to A plus B plus C plus D. Therefore, they are equal to each other. That is to say, AS plus BT equals to AB plus ST. Again, AS plus BT equals to AS. Again, AS plus BT equals to AB plus ST. So here AS equals to 2.5x. So we substitute AS by 2.5x plus BT plus ST. What is the value of ST? ST is 2 plus 1.5x. So we substitute ST by 2 plus 1.5x. 2 plus 1.5x. And it is equal to, again, AS plus BT. BT is 2x. So we substitute BT by 2x. And it is equal to AB. AB is 2 plus ST. ST is 2 plus 1.5x. So we substitute ST by 2.5x. So in total, we found out that 2.5x plus 2x equals to 2 plus 2 plus 1.5x. 2.5x plus 2x is 4.5x. 2 plus 2 is 4. So in total, in this equation, we have 4 plus 1.5x. So we found out that 4.5x equals to 4 plus 1.5x. Here we subtract 1.5x from this equation, and finally found out that 4.5x minus 1.5x is 3x. That is equal to 4. 3x equals to 4. We divided this equation by 3 and finally found out that x equals to 4 with 3 incident length. So the radius x of this circle equals to 4 with 3 incident length. Our mission is to find out the area of this circle. We know that the area of any circle equals to pi times the radius of the circle squared. So the area of our circle will be equal to pi times the radius squared. The radius is x, so it is pi x squared. And x is 4 over 3, therefore x squared is 4 over 3 squared. So in total the area of our circle equals to pi times 4 over 3 squared. So it is pi and 4 over 3 squared equals to 4 squared, that is 16, over 3 squared, that is 9. So in problem we found out that the area of our circle equals to either 16 pi over 9 square units, or in terms of numbers, the area of the circle equals to 5.585 square units. Okay, thank you very much.